Yo, 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 this is Mr. O, and today we're going to learn about trigonometry. But what's trigonometry? Trigonometry is a branch of mathematics that studies the relationship between the side lengths and angles of a triangle. So, in a triangle, we have three sides and three angles. Every side or angle of a triangle has a relationship that impacts the side length or the other part of the angles. Okay, so let's go ahead now. Trigonometric ratio. Um, let's analyze this triangle here. Okay, capital letters represent the angles in the triangles, and the smaller sides or the smaller letter, the lowercase, are the side of a triangle. If this is angle A, the opposite to angle A is side A. The opposite to angle B is side B. The opposite to the 90 degree, which is angle C, is the hypotenuse, which is side C. Now, let's remember that if this is my angle B, the opposite to angle B is side B. But my adjacent to angle B is side A, adjacent. Adjacent means sitting beside it, next to it, adjacent. Why not the C? Because C, I know, is sitting beside angle B, but that's not your adjacent because C there is your hypotenuse. The hypotenuse of this triangle is the one that opposite to 90-degree angle, which is side C. Same thing with angle B, angle A. The opposite to angle A is side A. This is the opposite. The hypotenuse of the triangle is still C. This is the hypotenuse. So therefore, side B is the one adjacent to angle A. So this is the adjacent. So looking at this problem here, what is opposite side to angle B? The opposite side to angle B is side B. What is adjacent to angle A? Adjacent to angle A is also side B. What's the hypotenuse of the triangle, which is side C? Okay. So there are three trigonometric ratio: the sine, the cosine, and the tangent. Sine is the ratio of the leg opposite to the angle and to the hypotenuse. That's why it's called so. Sine is opposite over hypotenuse. For the cosine, the ratio of the leg adjacent to the angle to the hypotenuse. That's why it's ka. Cosine is equal to the adjacent divided by the hypotenuse. And for the tangent, the ratio of the leg of the opposite of the angle to the leg adjacent to the angle sa TOA. Tangent is opposite over adjacent. If we look at this picture here, for our sine A, that means we go to angle A. Angle A is right here. This is the angle A. The opposite and the hypotenuse. The opposite to angle A is A over, what's the hypotenuse? C. So A over C is the answer. For sine B, where's the angle B? Angle B is right here, this blue one here. Opposite to angle B is B, side B, over the hypotenuse, which is C. So it's B over C. Cosine. Cosine of A is this orange one. Cosine means adjacent. The adjacent here is B. And the hypotenuse is C. So it's B over C. What about cosine B? So that means we go to angle B. That's B there, this black angle here. And adjacent over hypotenuse, adjacent to angle B is A. Hypotenuse is C. Okay. And the last one here for TOA, tangent is the ratio of opposite over adjacent. Opposite to angle A is A. And the adjacent is B. So A over B. And the tangent of B is opposite over adjacent, so it's going to be B over A. Okay? So remember that the trigonometry has three basic: the sine, cosine, and tangent. And sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So the easiest way to remember it, it's SOHCAHTOA. Soak your toe. Or they said some old hippie caught another hippie tripping on acid or anything. So that's how you do the Sokotoa. Okay, so let's do this one here. So I'm given a triangle ABC here, and we have to find for the ratio of sine A, cosine A, tangent A, sine C, cosine C, and tangent C. If you notice, we're not looking for the ratio for angle B because that measures 90. All the angles here are the acute angles only. Okay, the complementary. So anyway, so what is sine A? Again, it's SOHCAHTOA. Sine is opposite over hypotenuse. Opposite of angle A is 5. The hypotenuse of the triangle is 13. Cosine, what about cosine? Cosine of A is adjacent over hypotenuse, so it's going to be 12 over 13. And the tangent of tangent is opposite over adjacent is 5 over 12. For sine C. So sine C is the complement, angle C is the complementary to angle A. If this is 40, then this is automatically 50. That's why they're complementary. Okay, they have to be equal to 90 when you add them. So sine C is opposite over hypotenuse. Opposite to angle C is 12 over the hypotenuse 13. What do you notice about this? This is cosine of A and this sine of C. The C and the A, remember, are complementary. They have to have the same answer. Okay. Different views, but different same answer here. Okay. Cosine C. So cosine means adjacent. Adjacent is 5. The hypotenuse is 13. So 5 over 13. If you notice, that will be the same thing as right here and that one. Okay. For tangent, that's 5 over 12. If you remember a while ago, we had there A over B. Then this the answer for the other one is B over A. What do you think is the answer here? Okay, let's prove it. That the answer will be 12 over 5. Tangent C. They see the opposite over hypotenuse. Opposite is 12. And the adjacent is 5. So that's why it's a reciprocal of tangent A. All right, let's try to solve a triangle. Okay, this is where you're gonna need your graphing calculator, and make sure when you have your graphing calculator, hit the mode, and when you do the mode, make sure you're in the degree, not on radian, degree. Okay, if you don't know where to find it, please make sure you ask your teacher about it. Okay, so anyway, you have a triangle ABC here. B is 90. And the first thing you have to do here is identify what is given. Remember, the capital letter, the uppercase are your angles, and the lowercase one are your sides. So I know already that angle B is 90 because B is 9 there, and C is 28. And angle A, we do not know. I know that side B is 19 because it's opposite to angle B there. Okay. And we know that side C there is X. Okay, so whatever the X may be. So we have to find angle A, and side C. Okay, those are the things that are missing here. So what do we do here? First, we have to remember that they are equal to 180. The sum of the angles in a triangle is equal to 180. Or we can say that angle C and A are complementary. So 90 minus 28, that will give us 62. So we know that angle A is 62 there. Kaboom. Very simple, right? Next, we're going to apply trigonometric ratio in order for us to find side A and side C. We cannot use Pythagorean theorem because we're missing two sides. We can only use Pythagorean theorem when it's a right triangle and we know two sides of the triangle, of the right triangle. So we're gonna use trigonometric ratio. You can pick sine, cosine, or tangent. Depends on whatever you want it. Okay. But on this case here, and depends on also what you have. On this case here, we only have the hypotenuse. So we have to use only the SOHCA only. We can use the TOA, the tangent, because there's no hypotenuse. Whatever is given here is 19, which is the hypotenuse. So we have to use either sine or cosine. Let's pick sine. Sine of, let's say, angle 28 degrees, which is C, is equal to opposite. What's the opposite to angle 28? That's x over hypotenuse is 19. So we have to solve for x here by, or that x there is your side C, okay? This is over 1, we're going to cross multiply. So 1 times x is just x, and then 19 times sine 28. Remember, guys, that you do not multiply the 19 and 28. That's a degree. This is side measurement. So I like to tell my kids that, put the 19 in front of the sign. So just punch it in the calculator, 19 times sine 28. Make sure, again, you're in degree mode. The answer here is x is equal to 8.92 or 8.9. So therefore, C is 8.9 there. Now, we can use Pythagorean theorem to find side A because we know two sides of the right triangle already here. So since we're looking for this side A here, that's a leg, so x squared. No, I'm wrong. We're looking for, this is already 8.9, so we're looking for A squared, which is this side here, plus the leg, take note, it's the leg, which is 8.9 squared is equal to 19 squared, okay? So 8.9 squared is equal to 79.21, and this is 19 squared, which is 361 A squared. Subtract them, 361 minus 79.21. That gives us A squared is equal to 281.79. Take the square root of that, take the square root of that. Will give you 16, approximately 16.8. So this is 16.8. And there you go. We already solved the right triangle by knowing or identifying the three angles and the three sides using trigonometric ratio and Pythagorean theorem. And as always, kaboom!